Welcome back to Key Safety Talks. Today, we're going to be talking about statistics.
Okay.
And, statistics are really the backbone of making smart safety decisions.
Yeah.
It's about going beyond just kind of, your gut feelings about things and really using data to understand risk and make workplaces safer.
Yeah, you're absolutely right. You think of statistics as your safety detective toolkit.
Oh, okay.
It helps you uncover hidden patterns and predict potential problems,
Yeah.
improve the effectiveness of your safety efforts.
Okay, I'm intrigued, but I'll admit, like sometimes just looking at, all the numbers and safety reports,
Yeah.
it can feel a little overwhelming.
Yeah.
Where do we even begin?
Well, we start with the basics, like understanding what your data is telling you.
Okay.
And that's where descriptive statistics come in.
Okay.
It's like painting a picture of your safety landscape.
So it's about making sense of the raw data.
Exactly.
What are some of the key concepts we need to grasp?
Well, you have your measures of central tendency,
Yeah.
the mean, median, and mode. Okay. The mean is your average, which gives you kind of a general sense of the typical value in your data set.
So if we're looking at like the average number of safety incidents per month, that would be our mean.
Exactly. But sometimes the mean can be misleading, especially if you have extreme values or outliers in your data.
Okay.
Imagine you're analyzing injury severity, and there's one very serious incident that skews the average upwards.
So it makes the situation look worse than it typically is.
Right. In those cases, the median is a better indicator.
Okay.
It's the middle value when your data is arranged in order, so it's not affected by outliers.
So it's like finding the true center point of your data,
Precisely.
even when there's some extreme values.
Yeah, and then we have the mode, which is the most frequent value in your data set.
Right.
This is incredibly useful when you're trying to identify patterns or trends.
Can you give us an example of how the mode might be used in a safety context?
Absolutely. Let's say you're analyzing unsafe behaviors.
Okay.
By looking at the mode, you can determine the most common unsafe act that's occurring.
Right.
This allows you to focus your training efforts where they will have the biggest impact.
That makes so much sense.
Yeah.
Target the most frequent problem,
Right.
and you'll see the biggest improvement.
Exactly.
So we've got the mean, median, and mode, which give us a sense of the typical or central value.
Right.
But what about understanding how spread out our data is?
That's where variance and standard deviation come in.
Okay.
These measures tell us about the consistency or volatility of our data.
So are we talking about how much the individual data points deviate from that average we talked about?
Exactly. Variance gives you a sense of that spread.
Okay.
A high variance means your data is spread out over a wide range of values,
Right.
while a low variance indicates that the data points are clustered closely around the mean.
And standard deviation is related to variance, right?
Standard deviation is simply the square root of the variance.
Okay.
It's often preferred because it's expressed in the same units as your original data, making it easier to interpret.
So if we're looking at, say, near-miss data, would a high standard deviation be a cause for concern?
It certainly could be.
Okay.
A high standard deviation in near misses might suggest an unpredictable hazard or an inconsistent safety culture.
Yeah.
It's telling you that things are fluctuating a lot, which warrants further investigation.
It's like a warning sign that something isn't quite right
Right.
and needs a closer look.
Yeah.
This is fascinating. It's like we're starting to decode the language of data.
That's a great way to put it. And speaking of decoding, have you ever heard of the normal distribution or the bell curve?
Oh, yes.
Mm.
I vaguely remember that from my statistics class.
Uh-huh.
It's that symmetrical curve that shows how data is distributed.
Exactly. And what's remarkable about the normal distribution is that it allows us to make predictions about the probability of certain events occurring.
Predictions, that sounds powerful.
It is, for example, let's say we're looking at historical accident data.
Okay.
If that data follows a normal distribution, we can use it to estimate the likelihood of future accidents within a certain range.
So we can use past patterns to anticipate future risks. That's incredible.
Precisely. And the beauty of the normal distribution is that we know that a specific percentage of the data will fall within certain distances from the mean.
Like the 68, 95, 99.7 rule.
Yes.
Didn't 68% of the data fall within one standard deviation of the mean?
You've got it. And this relationship between standard deviations and probabilities is a fundamental principle in statistics, and it has a lot of practical applications in safety.
I'm starting to see that. But what if we want to compare safety performance across different departments or facilities that use different metrics.
Right.
How do we compare apples and oranges in the world of safety data?
That's where a handy tool called the Z-score comes in.
Okay.
Z-scores allow us to standardize data points, putting them on a common scale, even if the original measurements were different.
So it's like converting everything to a universal language for safety data.
Exactly.
Yeah.
Let's say you want to compare the safety performance of two plants, one that tracks incidents per 1,000 work hours and another that tracks incidents per month. Z-scores would allow you to standardize those rates and make a meaningful comparison.
That's brilliant. So we're not limited by different units or scales anymore. But I'm curious, how do we move from comparing data to understanding the relationships between different variables?
That brings us to correlation and causation, which is a crucial concept to grasp in any field, especially safety.
Ah, yes. The classic reminder that just because two things happen together doesn't mean one caused the other.
Exactly. It's easy to fall into the trap of assuming that correlation equals causation, but it's essential to remember that correlation simply indicates a relationship or connection between two variables.
Can you give us an example of a spurious correlation where there's a relationship but not a causal link?
Of course, there's the classic example of ice cream sales and drowning incidents.
Okay.
They tend to rise and fall together, but that doesn't mean eating ice cream causes people to drown.
Right. It's just that both are more common during the summer months when people are swimming more.
Exactly. The key takeaway is that correlation can be a starting point for investigation. But we need further evidence and careful analysis to establish a true cause and effect relationship.
So correlation can point us in the right direction,
Right.
but we need to dig deeper to uncover the real story. But how do we actually measure the strength of a relationship between variables?
That's where correlation coefficients come into play.
Okay.
They give us a numerical value that represents the strength and direction of the relationship.
So is there a specific type of correlation coefficient we would use in safety?
There are two common ones, Pearson and Spearman.
Okay.
The Pearson correlation coefficient is used when your data is normally distributed
Okay.
and measures linear relationships.
Linear meaning a straight line on a graph. Right.
Yes. The Spearman rank correlation coefficient is used for non-normally distributed data and focuses on rank order.
So we can choose the right tool depending on the type of data we're working with.
Mm-hmm.
Can you give us some examples of how correlation might be used in a safety context?
Absolutely.
Yeah.
Let's say you want to see if there's a relationship between the number of safety training hours employees receive and the number of incidents that occur.
Oh, okay.
You could use a correlation coefficient to analyze that.
That's a great example.
Yeah.
So we might find that more training hours are correlated with fewer incidents.
Mm-hmm.
But remember, correlation doesn't equal causation.
Right.
We can't automatically assume that the training directly caused the reduction in incidents. There could be other factors at play.
Exactly. Correlation gives us valuable insights, but we need to be careful about our interpretations.
This is so helpful. We're starting to move beyond simply describing data
Right.
to actually analyzing relationships. But how do we go a step further and test our assumptions about safety interventions?
That brings us to the exciting world of hypothesis testing.
Okay.
It's all about challenging our assumptions and looking for evidence to support our claims about safety improvements.
So we're putting our safety theories on trial. How does that work?
Essentially, we start with the null hypothesis, which is the assumption that there's no effect or relationship. Then we gather data and use statistical tests to see if we can reject that null hypothesis.
So it's like saying, we think this new safety program will reduce incidents,
Right.
but let's see if the data backs that up.
Precisely. And there are different types of tests we can use depending on the data and the research question.
Can you give us an example of a statistical test commonly used in safety?
The t-test is a very common one.
Okay.
It's used to compare the means of two groups.
So if we wanted to see if a new training program had a significant impact on incident rates, we could use a t-test to compare the average number of incidents before and after the training.
Exactly. If the t-test shows a statistically significant difference, it supports the idea that the training program had a real effect.
This is powerful stuff.
Yeah.
We can actually use data to prove the value of our safety efforts.
You got another commonly used test is the chi-square test, which is used to compare observed frequencies with expected frequencies.
So if we were analyzing the distribution of incident types, we could use a chi-square test to see if the observed distribution matched what we would expect based on historical data.
Precisely. And if there's a significant difference, it could indicate a shift in the types of incidents you're experiencing,
Right.
which might require adjustments to your safety program.
It's like having a data-driven early warning system. This is incredible. We've gone from basic descriptions to analyzing relationships to testing hypotheses. I feel like we're building a whole new understanding of how to use statistics in safety. But I'm curious, how do concepts like permutations and combinations fit into this picture?
Those are all about understanding possible outcomes, which is crucial in risk assessment and safety planning.
So permutations are used when the order of events matters.
Right. Imagine analyzing the steps in a hazardous process.
Okay.
The order in which those steps are performed could be critical to safety.
Yeah.
Permutations allow you to calculate the number of possible sequences.
And combinations are used when order is irrelevant.
Exactly. Let's say you're selecting team members for a safety audit.
Okay.
The order in which you choose them doesn't matter.
Right.
Combinations help you figure out how many different teams are possible.
I can see how those calculations could be helpful in identifying potential hazards or evaluating different scenarios.
Yep.
But my final question for this section is, how do we actually measure the reliability of a system?
Okay.
Like, how do we know how likely it is to fail?
That's where reliability engineering steps in.
Right.
Reliability is simply the probability that a system or component will perform its intended function for a specific period under stated conditions.
So higher reliability means it's less likely to fail, which is obviously a good thing in safety.
Absolutely. We can calculate reliability for both individual components and for complex systems.
Okay, this is getting interesting.
Yeah.
But how do we calculate the reliability of a system? I imagine it gets complicated with multiple components.
It can. In a serious system, all components must function correctly for the system to work.
Okay.
If one fails, the whole system fails.
Like a chain. If one link breaks, the whole chain is useless.
Precisely. But in a parallel system, there's redundancy built in.
Okay.
The system will continue to function as long as at least one of the parallel components is working.
So it's like having multiple backups in case one component fails.
Exactly. Calculating the reliability of parallel systems involves a bit more complex math.
Right.
But the concept is straightforward. We're looking at the probability that at least one component will succeed.
This is all starting to make sense. We can analyze individual components and then consider how they're arranged to understand the overall system reliability.
And don't forget about the probability of failure.
Right.
It's simply the complement of reliability.
Correct.
If a system has a 90% reliability, its probability of failure is 10%.
So we can use these concepts to quantify the likelihood of failures and make informed decisions about system design and maintenance.
Exactly. And that brings us to the end of our foundational exploration of statistics and safety.
This has been an incredible journey so far. We've covered a lot of ground, from basic descriptive statistics to complex concepts like reliability engineering.
Yeah.
But I'm eager to hear more about how these concepts are applied in real-world safety scenarios.
Yeah.
So stay tuned for part 2, where we'll dive into some fascinating case studies and practical applications of statistics in action.
Sounds great.
So we've laid a really solid foundation of these statistical concepts,
Yeah.
Now I'm really curious to see how these tools are actually being used in the field.
Uh-huh.
Can we dive into some real-world examples?
Absolutely. One of the most powerful applications of statistics and safety is in accident investigation.
Okay.
It's about going beyond simply describing what happened and digging deeper to understand why it happened.
So we're talking about using data to uncover the root causes of accidents.
Exactly. Take, for instance, the Deepwater Horizon oil spill in 2010.
Oh, wow. Yeah.
That disaster resulted in a massive environmental impact and the loss of 11 lives.
Huh.
And it really highlighted the critical importance of understanding complex systems and their potential failure points.
That's a tragic example, and one that definitely underscores the need for rigorous investigation to prevent those things from happening again.
Absolutely. In the aftermath of accidents, like Deepwater Horizon investigators often use statistical techniques like fault tree analysis
Okay.
and event tree analysis to piece together the chain of events that led to the disaster.
It sounds like those techniques involve breaking down a complex system into its individual components.
Yes.
And analyzing the probability of failure for each one.
You're exactly right. It's like creating a detailed map of all the potential pathways that could lead to an accident.
Wow.
By analyzing the probability of each component, failing investigators can pinpoint the most critical weaknesses in the system
Yeah.
and recommend changes to prevent similar accidents from happening again.
That's fascinating. It's like we're using statistics to almost turn a tragic event into an opportunity for learning and improvement.
Precisely. And another area where statistics plays a vital role is in risk assessment.
Oh.
It helps us move beyond subjective opinions and gut feelings
Right.
to make more objective and data-driven decisions about safety.
Okay. Risk assessment is a term we hear all the time in safety.
Yes.
But how do these statistical concepts actually help us assess and quantify risk?
Well, remember those concepts of probability and frequency we discussed earlier?
Like The likelihood of something happening and how often it might occur?
Exactly. In risk assessment, we often use matrices or other tools
Okay.
to combine the likelihood of an event with its potential severity
Yeah.
to determine the overall risk level.
So a highly likely event with catastrophic consequences would have a much higher risk level
Yes.
than a rare event with minor consequences.
Precisely. And by quantifying risk in this way, we can prioritize our resources
Right.
and focus on the most critical hazards.
Yeah.
It helps us answer the question, where should we invest our time and resources to have the biggest impact on safety?
That's incredibly valuable. It takes the guesswork out of safety decision-making.
Another powerful application of statistics is in benchmarking.
Okay.
It allows us to compare our safety performance to industry averages, best practices, or even our own past performance.
So it's like comparing our safety report card to the rest of the class.
Exactly. It helps us understand where we stand in relation to others and identify areas where we need to improve.
Yeah.
And just like in school, seeing how we stack up against others can be a powerful motivator for continuous improvement.
I love that it provides a clear target to strive for.
And one final example I want to highlight is the use of statistical process control in safety.
Statistical process control.
Yeah.
That sounds intriguing. Can you tell us more about that?
This technique is all about monitoring processes over time to identify any trends or shifts that could indicate a potential safety issue.
Oh, yeah.
It's like taking the pulse of our safety systems to make sure everything is running smoothly.
So we're not just looking at individual data points,
Right.
but rather at the overall pattern of data over time.
Exactly. We can use control charts and other statistical tools to track key safety metrics like incident rates, near-miss frequencies,
Yeah.
or even leading indicators like safety observations.
And if we see any unusual patterns or deviations from the norm,
Yes.
it could be an early warning sign that something needs attention.
Precisely. It's like catching a problem before it turns into a full-blown crisis.
Right.
It allows us to be proactive rather than reactive in our safety management.
This is amazing. It's like having a crystal ball that helps us anticipate and prevent safety issues before they occur. But with all this talk about the power of statistics,
Yeah.
are there any limitations or challenges we should be aware of?
That's a great question. While statistics is an incredibly powerful tool, it's important to use it wisely and be aware of its potential pitfalls.
So what are some of the traps we should watch out for?
One of the biggest challenges is ensuring data quality.
Okay.
Remember the saying, garbage in, garbage out?
Right.
If our data is inaccurate, incomplete, or biased, our statistical analyses will be flawed.
That makes perfect sense. We need to make sure we're starting with reliable data before we start crunching numbers.
Absolutely. Another common mistake is misinterpreting statistical results.
Okay.
It's easy to get caught up in the numbers and jump to conclusions that aren't actually supported by the data.
So we need to be critical thinkers and avoid making assumptions just because we see a correlation or a statistically significant result.
Exactly. It's important to consider the context, look for alternative explanations, and be willing to question our initial assumptions.
It's like being a safety detective, always searching for the truth behind the data.
Precisely. And finally, another challenge is communicating statistical information effectively.
Okay.
It's one thing to understand the numbers ourselves,
Right.
but how do we explain them to others in a way that's clear, concise, and compelling?
Right. We need to make sure our insights are actionable. How can we overcome that communication barrier?
That's where data visualization and storytelling come in. Instead of just presenting raw data, we need to find ways to bring it to life with charts, graphs, and narratives that engage people and help them understand the key takeaways.
So it's about turning data into a story that people can connect with and act upon.
Exactly. And that's a skill that every safety professional should develop. It's about bridging the gap between data analysis and real-world decision-making.
This has been a truly enlightening conversation. We've explored the power of statistics and safety, from understanding basic concepts
Yeah.
to applying them in real-world scenarios, and even discuss the importance of data quality and ethical considerations.
It's been a pleasure sharing these insights with you, and I hope our listeners feel inspired to continue their journey of learning and applying statistics in their own safety practices.
I couldn't agree more. So as we're wrapping up our exploration of statistics and safety, what's the one key takeaway you want our listeners to walk away with?
I think the most important message is that statistics isn't just some theoretical subject, just for academics. It's really a practical toolkit that every safety professional can use to make a real difference.
Yeah, I love that it's about empowering people with the knowledge and skills
Exactly.
to create safer workplaces.
By embracing data and statistical thinking, we can move beyond just intuition and make more informed, evidence-based decisions that really protect lives and prevent injuries.
So for our listeners who are maybe just starting their journey with statistics,
Yeah.
what advice would you give them?
Well, I would say don't be intimidated by the complexity.
Right.
Start with the basics and build from there. Get comfortable with those descriptive statistics we talked about, mean, median, mode, variance, standard deviation.
Yeah.
Those are the foundation.
Yeah, it's like learning the alphabet before you can write a novel.
Exactly. Once you have a solid grasp of the fundamentals, you can start exploring more advanced concepts like hypothesis testing, correlation, and regression analysis.
Right.
There are tons of resources available, online courses, books, workshops that can guide you along the way.
Yeah, and don't be afraid to reach out to experts in the field for guidance and support.
Absolutely. The safety community is full of passionate individuals who are eager to share their knowledge and help others succeed.
Right. It's all about that continuous learning and improvement.
Speaking of improvement, one thing I want to emphasize is the importance of using statistics ethically and responsibly.
Oh, that's a crucial point.
Yeah.
Yeah, we've talked about the power of data, but with great power comes great responsibility.
Right, we need to be mindful of data privacy, avoid bias in our analyses, and always be transparent about our methods and findings. Statistics should be used to illuminate the truth, not to manipulate or mislead.
Yeah, it's about using data to make the world a safer place, not to advance personal agendas or justify preconceived notions.
Well said. Ultimately, statistics is a tool for good. It's about using data to understand risk-prevent accidents and save lives. And that's a mission worth pursuing.
This has been an incredible journey through the world of statistics and safety. We've covered a lot of ground from the, foundational concepts to real-world applications and even touched on the ethical considerations.
Yeah.
I hope our listeners feel inspired and empowered to incorporate statistical thinking into their own safety practices.
I couldn't agree more. Remember, statistics isn't just about numbers.
Right.
It's about using data to make a positive impact on the world. And that's something we can all strive for.
Thank you so much for sharing your expertise with us today. It's been a truly enlightening conversation.
It's been my pleasure. Stay safe out there, everyone.
And to all our safety champions listening, keep learning, keep innovating, and keep using data to make a difference. Until next time, stay safe.